All right, so we've already run into finding areas, and I mentioned it before, but I'll mention it again. When you're working with a probability distribution function like we are, then when you're finding the area under the curve, you're finding the probability. They are one and the same. And if it's probability, then you can notate it with the probability distribution, the probability symbols that we worked from chapter 5, i.e. capital P and then a parentheses. It's just that we're not going to say like x equals 2 like we would in chapter 5 and 6. What we're going to say is z is this way, or z is greater than that, or z is less than this, right? Now notice, real quick, I'm going to make a note of it down here. It doesn't matter whether they say less than or equal to or whatever, because remember that the equal to part is just the actual bar. It doesn't actually have any area, so it's irrelevant whether you include it or not. So I've already drawn the picture here. The picture here is 0.65, which is this bar right here, all the way up to 2.1. I don't know if you can see it. It's really small, but it's right there, right just past the 2. And I've shaded in between. Now what I want to do is I want to find the area of what I've shaded here. So let me scroll down so we can see this. Okay, so the problem that you're going to run into, number 3, is that Excel only finds left areas. It only finds left probabilities. It only works with left probabilities. So if you look here, I have 2 probabilities, right? Two numbers I'm going to need to find. So I could find the area to the left of 2.10. That wouldn't be hard to do. That would be equal to norm dot dist, right? Now why dot dist? Now why not dot inverse? Bear with me. Well, I've given you z-scores. When you're given a z-score like 2.10, you have to be using the dot dist function. You couldn't possibly be using the dot inv function, inv. The inverse function only works when you want to know the z-score, i.e. it wasn't given to you, but ours was. So it's 2.10, comma 0, comma 1. Oh, oops, forgot the true part. Hold on. Yes, I know. 0, comma 1, comma true. There we go. All right. So think about what that means. Here's 2.10 right here. We're in the right. All of this stuff, the shaded part and the unshaded part, makes 0.98. Well, how could I find just the shaded part? Well, I could also find the area to the left of 0.65. Now that would be equal to norm dist, and again the dot thing might not exist if you're working off of Excel 2007 or earlier, but it'll be the same type of function. So you take 0.65, comma 0, comma 1, comma true. All right, and that is the white area right here. That's 0.742. So how can I find just the shaded one? Well, the shaded area between 0.65 and 2.10 is equal to this minus this, right? The larger probability minus the smaller probability. And notice that's the same thing as probability of 0.65 is less than z, which is less than 2.10. It's the same thing. When you're writing this probability thing, you're writing the same thing as this area. They're one and the same. And both of them make 0.23998. Which if you were going to round to 4 decimal places would be 0.2400, right? Because the 8 would round the 9 up, the 9 would round the other 9 up, and that 9 would round the 4. There's me, the 3 to a 4. And then again, I just made a note of it down here. It doesn't matter whether you think of the 0.65 and the 2.10 as solid lines or dotted lines. It doesn't make any difference because they have no area, therefore they can't affect the final result. All right, we're done with section 7.2. I hope you enjoyed it. I'll see you here next time for 7.3, the regular normal distribution, not the standard one, but the one that's for anything.